Hi, let's continue on integration by substitution. Another example, now this time involves square root in a fraction form. So it looks a little bit more complicated, but it's kind of the same. We just need to change the fractions, or sorry, the roots in the fraction as indices. So let's have a look. Find integrating x squared over square root of 2x cubed minus 4 dx. Now this time it's pretty much the same, but it just look a little bit more complicated. So if you rewrite this, the bottom part as the power of negative a half, that is pretty much the same as what we did here instead of power of 5. So in this case, we will let u equals to 2x cubed minus 4. And as usual, we find out the derivative, which is 6x squared. And du equals to 6x squared dx. And remember, we don't have 6x squared, we only have x squared. So you make up the substitution exactly the same in the question. So therefore, in this case, combine this again, becomes du on 6, and whatever inside here is u, so therefore is 1 on u, square root of u, du over 6. And then you can take out the constant 1 on 6 and rewrite this as u to the power of negative half. And then just do normal integration, which is 1 on 6 times u to the power of half, negative half plus 1 is half, divided by half plus c. And then, therefore, now divided by half, that's times 2, 1 on 3, u to the power of half plus c. And if we rewrite this as what we got before, that should be 2x cubed minus 4 to the power of half plus c. And that is, in fact, the square root of it. Okay, now, these are just standard way of doing integration by substitution, which we just make the target function as u, and then we replace all the dx with du. If we have a question a little bit more complicated, which we need to do a little bit more substitution, such as x square root of x plus 5 dx. Now in this case, it's a good idea to just let u equals to x plus 5. Not the square root of x plus 5, just x plus 5. In this case, du over dx is just 1, which means du is exactly the same as dx. So you can replace your dx by du without any so-called component. And since we also need to replace the x at the top, that means if u equals to x plus 5, x equals to u minus 5. So therefore now we can replace every single term inside this integral, including x plus 5, dx by u, like this. Now this is a little bit challenging, well, kind of. You can put u to the power of half at the bottom, and then you just need to split it. Basically, u minus 5 on u half du, and then if you want to go, u on u half minus 5 on u half du, and that just becomes, that's u to the power of half, 1 minus half is half, minus 5 u to the power of negative half. And then do your normal integration from this part onward. So the integral of u to the power of half, that is u to the power of 3 over 2 over 3 over 2, minus 5 times u to the power of half over half, because negative half plus 1 is half again. That will give us 2 on 3, u to the power of 3 on 2, minus 10 u to the power of half plus c, substituted back in, u is x plus 5. And if I put it back into the third form, there should be square root of x plus 5 to the power of 3 minus 10 times square root of x plus 5 plus c. In this case, we have also replaced any single linear x by whatever substitution you make for u correspondingly. Okay, so this is pretty much similar, but let's do a few more questions on this. Find integrating x over square root of 2x minus 5 dx. Let the substitution by u equals to 2x minus 5. Therefore, du over dx equals to 2. And du on 2 equals to dx. Why? Because we only can replace the dx in here. And then because u equals to 2x minus 5, you need to also substitute for this x. That is 2x equals to u plus 5, x equals to half u plus 5. Just a constant, so therefore we'll take it out in a minute. Therefore, now in this case, now the top x becomes half u plus 5. The bottom is square root of u. And the dx is du on 2. So now this is take out half, another half, therefore a quarter out. And then if we split it, it becomes like this. And then change it back into index form. That will be u to the half plus 5u negative half. And then do normal integration, u to the power of, so a quarter, u to the power of 3 over 2 over 3 over 2 plus 5 u to the power of half over half plus c. And then it's just a quarter. Now, inside that is 2 on 3, u 3 on 2 plus 10 again, u to the power of half plus c. And you need to replace the u again by your original function, 2x minus 5 to the power of 3 on 2 plus 10 times 2x minus 5 to the power of half plus c. And then it's up to you whether you want to expand it or not. Well, doesn't really matter. So you put it in, that's 1 on 6. Square root of 2x minus 5 to the power of 3 plus 5 on 2. 2x minus 5 to the power of half, that is square root of 2x minus 5 plus c. Okay, so it's pretty much similar. Now, we haven't done a lot of things that to find the constant. This is a great time to actually do that. So for example, before I do this, let's make the notes. When completing an indefinite integral, we have the plus c. For questions that requires the actual function we need one set of values to find each c, because sometimes you can actually integrate it twice. So for example, if the gradient of a curve is dy over dx equals to x times 3x squared minus 1 to the power of, let's say, I don't know, 2. And the point 0, 1, 0, 1. Is 0 a good number? Yeah. 0, negative third. Lies on the curve, then find the equation of the function. Now, if dy dx equals to this, to find the function, we need to integrate it, obviously, because this is already the derivative. Now, therefore, y equals to integrating x 3x minus 1 squared. Okay. Now, in this particular case, let's do integration by substitution. Let u equals to 3x squared minus 1. dy du over dx equals to 6x squared. Therefore, du equals to 6x squared dx. And du on 6 equals x squared dx. Why is that? Because we only got x in here. Sorry about not writing dx. Oops, did I make a mistake? Yes, I did. 6x, not 6x squared. All right, so therefore now let's replace. So that is u to the power of 2, u over 6. All right. Okay, so in this case, therefore, if you integrate it, that will give us 1 on 6, u 3 on 3, plus c. That is u to the power of 3 on 18 plus c. All right, so remember, that's not the end of question. We needed to change it back into x. All right, so in this case, now we are looking for the equation. That's not the equation because you still got a non plus c there. So that is when, because it says it passes through the point 0 and negative a third. All right, in this case, that means when x equals to 0, y equals to negative a third. That is negative a third equals to 0 minus 1 cube on 18 plus c. So therefore, that one is negative 1 on 18 plus c. C equals to negative third plus negative 1 on 18. So that becomes negative 2 on 18. That is negative 1 on 9. Is it? Not really. I made a mistake. 6 plus 1. 6 plus 1. Oh, minus 1. That's 5. Negative 5 on 18. So c equals negative 5 on 18. Therefore, now you need to rewrite your function. Therefore, y equals to 3x squared minus 1 to the power of 3 over 18 minus 5 on 18. That is your answer. That is a complete answer for the function by finding the c through the set of values 0 and